Hi there, nice to see you back here on the School of Quantum. And I hope you're ready for another episode of the Hidden Quantum Champions. Today we are going to look at a company called Quantum Dice. It says verifiable true randomness. And with that, I think let's dive right into the website and discover what they have to offer. So it is about randomness. That's something that we can see here already. And it says harnessing the quantum properties of light to solve some of today's most critical computational challenges. Sounds to me like we are talking about quantum-based random number generation, if I would guess. But we will figure out more as we go along the website. So it says about quantum dice. Since spinning out of the University of Oxford's world-renowned quantum optics lab in 2020, we've developed a range of products and solutions that leverage the unique properties of quantum systems and our patented disk protocol. Our solutions are already deployed in the UK and internationally, and we are committed to tackling some of the biggest computational challenges of the modern age. What makes our technology unique? There's this disk protocol, our applications, so they are in the cybersecurity space. Our cybersecurity solutions provide verifiable, secure random numbers to enable secure encryption. So as I was guessing, I guess I'm right, so random number generation, and that in this case for cybersecurity. So if you want to create a key for something, you might need some type of seed phrase, and that ideally is like a random thing. So here you have this quantum number generator that actually produces a random number secured by quantum mechanics. So quick step back. If you want to create with a computer a random number, this is always a bit of a challenging thing, because computers by definition are deterministic machines, which means when you have a computer, like a very simple one with, a couple of bits and some gates between them, AND gates, OR gates, whatever, and you turn on the gates, you can exactly predict what will come out. That basically means that whenever you start a computer, you can already predict the things that it's going to do, which is good for everyday life because if you start it up, it starts the operating system and everything should look exactly the same. We know that like in real life, sometimes computers don't do what we actually want them to do, but technically they're deterministic machines. There's no such thing as true randomness in here. Now, there are functions that generate random numbers, but actually there's an algorithm behind that. So it's not an actual random number, but maybe it takes, the today's date and the time that is being measured and multiplies it by some number and then factors it by some other number. And at the end you get out a random number, but actually it's not a random number, even though like when you run it, you always get a different number. That's just because time goes on and the machine has a different timestamp. Just one example. So that in turn basically means that it's not 100% secure, because if somebody knows all the input parameters and knows when you generated the key, they might be able to figure out, they might be able to figure out what was the random number that has been used. For that reason, it would be interesting to have something that produces actual randomness. And here is where quantum mechanics comes in. If you have a quantum system, let's say a two-level system as in a quantum bit, and you put it in a so-called superposition, it goes into a state where it's neither in the one state nor in the zero state, but at some probability it is in the one state and at some probability it's in the zero state, more or less. This is now a very simplified image of the whole situation, but only when you measure this state collapses, we say collapses, into 1 or 0. But you cannot really predict in which of these two it will collapse. So you cannot really say, is it going to be 1 or 0? You can only say at a specific probability that it's going to be 1 or 0. So if you create a perfect superposition, for example, between 1 and 0, there's a 50% chance that the outcome will be 1 and a 50% chance that it's going to be 0. And there's no theory at this point in time that can actually predict whether you're going to measure 1 or 0 at a specific event. Only a probability. And that's kind of at the core of this whole technology. There's like different derivatives and different ideas of how you can actually apply this. So for example, if you look at radioactive decays, if you have radioactive atoms, they decay into two different atoms. But we cannot really say at which point in time that, for example, happens. There's only something that we call like a half-life time. So that's like a statistical number. But if you look at a single instance at one single atom, you cannot actually say exactly when it decays. There's no theory that can actually tell you right now because it's a quantum process. So you see there's like different variations of the same idea, but they all use this type of randomness that is provided by the idea of quantum mechanics. And that's probably what is being used somehow in here. I don't think they're using radioactive in here, but like some other idea of how to create a superposition. Now, one part that this is being used is in cybersecurity that we just saw, like quantum entropy as a service, hardware, and QRNG backed solutions. The other side here is stochastic computing. Our technology enhances stochastic methods and statistical simulations such as Monte Carlo simulation. So Monte Carlo simulation is an idea where you basically use randomness in your simulation. So you have a super huge complex problem which consists out of small sub-problems, and now you do the computation of these sub-problems, but you pick them randomly, like you randomly decide which one you actually compute. You don't maybe not compute all of them. Now, if you want to do this in a proper way, you actually also need a good randomness, like a truly equally distributed randomness, because let's say you're trying to compute a 2D array, like with, I don't know, let's say you are looking at a crystal, a magnet, and you want to calculate the magnetic orientation of this magnet. Now, if you have a function which does not really pick truly random numbers, you might only end up calculating the right or the left side of the magnet. So you're kind of biasing the whole system, because if you do more calculations in one area than in the other, it basically affects the overall system. So you need a good random number, and that's why you also see it in stochastic computing here. Then you see supported by, so you see a lot of big names and labels here featured in. So there's like Google for startups, banking, risk and regulation, Forbes 30 under 30, and so on, like kind of known things. There's latest news and blogs. I'm recording this end of August. The latest news article here, or the latest article here, is also from end of August. You see QRNGs and the future of secure systems, takeaways from the NCSC's Quantum Networking Technologies white paper. Okay, and then there's some way to get in touch with them. Down here it says they are based in the United Kingdom, which is something that we've seen before because they're an Oxford spin-off. Now, we have seen that. Let's quickly take a look into the applications here. We see there's like the cybersecurity, so there's the cybersecurity and the stochastic computing up here. The sectors are telecom, finance, and cybersecurity. The sectors they're working with is telecom, finance and banking, government and defense and space. And the offerings that they have for these specific types of sectors is the QEAAS, hardware, QRNG backed solutions, and then there's customer success. There's also some case studies here. Likewise, for the stochastic computing, we again have finance and banking, biotech and pharma, AI, and machine learning. And then there's the Metropolis Cloud, and there's also some customer success story. Maybe quickly take a look into the offerings. So we see here the QEAAS, which is the quantum entropy as a service. Tens of billions of IoT devices will soon be part of our daily lives. This is so IoT is the Internet of Things, like small devices that are connected to the internet. I don't know, your fridge, your light bulb, whatever, your vacuum cleaner, robot, they are all IoT devices in a way, offering immense convenience. However, these devices often lack the computational power necessary for secure cryptography. Like, for example, your normal computer does, because your light bulb doesn't have the same computational power that, I don't know, your smartphone or your tablet has. So the solution to address this, Quantum Dice offers the QEAAS, so quantum entropy as a service. The quantum entropy as a service leverages our disk-protected quantum random number generators, QRNGs, to distribute entropy across remote servers, ensuring that even the most resource-limited devices and cloud instances receive the secure, certified randomness they need to implement all the cryptographic functions. Okay. Here you see the benefits: enhanced security, certifiable entropy, scalability, easy integration, and cost effectiveness. So then we have the use cases: encryption, key management, network security, app development. So that looks to me like we have some type of API, so some type of software interface that where you can retrieve actual random numbers, and you don't have to calculate them right on the device. So then there's like hardware here. This is their QRNG hardware solution. So the quantum random number generator offers the best-in-class security at ultra-fast generation rates. That's another important thing, right? So first you need to make sure, okay, this is actually pretty solid random number generation, but like it should be random enough, right? It should be very random. That's like the idea of it. But then you also got to make sure that you have enough of these numbers, because if you look at like bigger compute problems, it might not be enough to have just one number per second, right? So you need to create something that has a high bandwidth, and that's apparently what they also have here, like ultra fast generation rates. At the core of all our solutions is our patented disk protocol, which performs a continuous entropy evaluation on each key, providing live quantum assurance. So there we see Vertex, which is PCIe QRNG. So PCIe is like a standard slot that you can put in a computer, like a GPU. You can insert this Vertex here, and then it produces random numbers, probably at very high rates, because this PCIe slot actually has a pretty high bandwidth in terms of data. And then there's the Apex, so a 19 inch rack mount QRNG. So this is what goes into a whole server. So this one is probably for like a bigger computer, like an edge cloud type of device. This one really goes into a server center where you have like the whole racks full of computers. And now you say, okay, I need random number generation. So you put one rack in there, and this one probably gives you even more random numbers than this one. But for sure, both of them do way more than one random number per second. Okay, then quickly look here at the QRNG-backed solutions. Just to see what they have here. So there's like co-developed solutions and integrations. So Quantum Dice and Thales, QRNG-backed Luna, HSMS. So that's like both of them look like they are projects together with others. So IQ, ELA, and Quantum Dice offer Quantum Enhanced Virtual Extended Network (VEN) solution to ensure verifiable, secure encryption keys. So probably like in the networking space. And then Thales, we know, is like a big European technology provider that is working in various different areas. Okay. So finally, in this, we also want to look at the Metropolis Cloud. It's probably a cloud solution, right? So stochastic methods and statistical simulations, such as Monte Carlo simulations, are an essential part of the modern economy. They are used across a wide range of applications in industries such as pricing complex financial instruments, portfolio optimization, climate modeling, and drug discovery. So again, we have like finance, we have climate modeling, so environmental science, and the drug discovery as in pharmaceutical. We also see here machine learning based things and science and engineering and insurance. Okay, the accuracy and efficiency of these simulations have a tremendous direct impact on the bottom line of organization operating in those sectors, affecting both their budget and their ability to make correct decision. Okay, then we see here that the random sampling is an important part of that. And now here the solution, all probabilistic behavior on a computer is currently simulated by deterministic algorithms. That's what I was explaining earlier on, and therefore only provide random looking patterns rather than true randomness. Metropolis Cloud solves this problem because it leverages our high-speed reliability and high-optimized architecture for randomness generation using quantum photonics. So that also explains now what is the underlying technology. So they use photonics, so light, basically, the randomness of light to generate those numbers. So you see here fewer computational steps and improved accuracy because of the fact that you are using actual random numbers and you don't have any bias in those randomness anymore. And I guess it comes as a cloud solution, so you can basically probably again get a account there and use their cloud to do this calculation. Now what I would be interested in to understand here is like, is it a cloud as in you get an API access and you can draw random numbers from their cloud, or is it like they have it integrated somewhere in an actual cloud service? Like I don't know, in Germany there's Hetzner, and they have basically put one of the systems at Hetzner side, and now you can basically get access via them. I don't know, but that would be interesting to understand here as well. Let's quickly check out the company as well. And maybe we start with the core technology, disk, so generating random numbers. And with photonics, as we learned before, there's some story here about the random numbers and the disadvantages of current systems. Then what disk is going to deliver here. And then there's something here about the solutions, but I think we've seen that before. So let's check out the company very quickly. Here we see again, it's a Oxford spin-off. The company was founded in April 2020. Quantum-Dice is an award-winning venture-backed spin-out of the University of Oxford's world-renowned quantum optics lab. Quantum-Dice is working to solve one of the longest standing problems in computing, generating trusted and reliable randomness. We have developed the world's first scalable source device, independent continuous assuring quantum random number generator, QRNG, with applications in both cybersecurity and stochastic computing. Our range of disk protected QRNG solutions have a wide range of use cases in numerous sectors, ranging from communication security to AI optimization. Then there's a video which explains it. We see the leadership team here, as well as some other team members. And then of course there's like some way to apply here or to see the open positions and some awards that they have won. So I think that was an interesting one as well, because now this is like not your typical quantum computing or quantum computing company, which has a roadmap until far in the future at which it becomes useful, but they are like actually already catering to industries. This is, let's say, it looks to me like a solid product. It comes in different form factors that can go into existing computers. So that looks like something that is actually already in use. So maybe some other perspective on where quantum technology is already being applied maybe into products that we are using in every day, right? Maybe something has been simulated with this already. I hope you found this interesting. I definitely found it a very interesting journey today. If you liked it, please make sure to subscribe to the channel so you don't miss out on the next video. And with that, I would say let's make sure we stay hydrated and then see each other in the next one. Bye bye.